thanks so much for coming today. We've got some really iconic companies in defense that are doing some really interesting things with machine learning, and so I'm really stoked about the panel that we've got here. I thought a good question to open with would be, what kind of impact each of you thinks machine learning can bring to defense, right? When you think about technologies that have transformed the defense industry, some of them have honestly shifted power balances between the superpowers. Some of them are a little bit more incremental. It'd be great to kind of get your thinking and framework around how impactful machine learning can be. Maybe we'll start with you, Brandon.
Sure. It's a really great question. I think I'll actually start. Russia's President Vladimir Putin said, "Whoever leads in AI will rule the world." China has said that they intend to lead in AI by, I think, 2025. And I think that every single superpower or emerging superpower is looking at what AI can do for national security and what it means to the world. And from my perspective, it is perhaps the most transformational technology as it relates to national security. The focus on software, the focus on AI will fundamentally transform the defense industry, which has been a primarily hardware-focused industry for the past 120 years, or ever since the defense industrial base, I would say, it really got going in World War I. And so I think about what software and what AI mean to the industry. And I think you can look at a number of other different industries and how software and AI disrupted those industries, whether it was computing, whether it was phones, whether it was the automobile industry. And so I think the impacts are going to be massive. I think it is perhaps the most exciting, when I think about exciting places to be in, exciting spaces to be in, the intersection of AI, national security, and call it building a business, scaling a business. I don't think there gets to be a more exciting space to be in. And when I was leaving the SEAL teams, the number one thing I was looking for post-career in the Navy was to have impact on the world, to have a big positive impact. And I think, I'm happy to say I think I found a space where I can continue to have big positive impact. And I truly believe the sky is the limit in the space that these three companies are playing in right now.
And Mike, you're with Lockheed, which has obviously been in the defense game a long time and has seen a lot of these technology revolutions kind of wash over the defense industry. Would love to get your thoughts on the same question.
Yeah, I think probably the most obvious way is continuing to take people out of the direct harm's way in these fights. So we're moving into the cyber world, talking about software, and wars will be fought on computers. We're moving into the world of autonomy and unmanned aircraft and getting people out of those flying things. And behind, staying in safe areas and sending equipment in that doesn't need humans on it. So certainly the direct impact to human life is going to be something that is directly affected. And then that's going to introduce, I think, new effects, which are going to be the indirect and longer term effects of cyber warfare. And if we're talking about like hacking the power grid and things like that, like you might not be making immediate impact, but if you do that over long periods of time, you're affecting very large populations of people in longer term, very negative ways. So it's going to be interesting to see how that plays out over the coming decades.
Got it. Cool. Next question I had, and perhaps this will kind of resonate with the data scientists here, is when you think about and Gokul, I'll go to you on this one. When you think about how building machine learning is different in defense versus in other kind of commercial industries, what are some of the ways in which you think it's different, whether that's from a development perspective or from a user perspective or from an organizational perspective?
Yeah, that's a great question. I'll play on what my two co-speakers here have talked about, but things that are very different in the defense industry. The scale is enormous. You're working at a nation-state level of capability, from air to ground to space to underwater. And so you're taking into account data that is very disparate, very heterogeneous, and figuring out how do you build, really the thing is, how do you build systems around these things where, you've got multiple models playing together, multiple systems working together. How do you do it in a safe, how do you do it in a reliable way? How do you do it with operators in the loop where there's doctrine that's been developed by, the militaries of the world? So the scale is humongous. The types of data that you work with are very different than you might see in commercial space. I've got a video, we'll get through it later today, but something like medium wave infrared cameras, not traditionally used in, maybe automobile self-driving is using it today, but not traditionally used in most industries. You've got satellite imagery, you've got synthetic aperture radar. So just the types of data is enormous and the problem sets are diverse. And the other thing that I want to touch on is that you're really dealing with a distributed environment problem. So, we are not Tesla where we can have one model to rule them all or one server to rule them all. All the data can't come back home to us. Often our users are deployed, in forward environments where they have no connectivity. So how do you do machine learning in a situation where you can't bring all the data back home? You can't even see some of the data. How do you update your models real time in the field? And then the last thing that I want to harp on is that the stakes are enormous as well. So we work in counter drone, so defending U.S. bases against drone attacks. And I like to say to folks who don't work in the field, you guys will know this very well, but I like to say that the denominator really matters. And what I mean by that is that if your system can pick up 99% of the drones that come in, but you miss one, that could still be a difference between life and death. And so the kind of stakes that you're playing at, the types of sensors that you're using, the types of data sets that you're using, and the challenges that come with the environments that you're deployed into, I think that's what really separates defense or makes it unique from some of the other fields. And I think you can see a lot of that, by the way, in what's happening in the news today. Just what happened starting in February with Russia invading Ukraine. I think that makes it very tactile for a lot of folks why this field really matters.
Can I actually add something on top of that? And I think it's this, this concept of AI in the defense industry or ML in the defense industry versus other industries. One of the things that Shield AI experienced that I think is really interesting, it has to do with the reliability of systems. And you actually see the DoD pushing harder, faster, taking way more risk than any enterprise customer or any consumer would ever think about as they think about reliable AI systems. And so what we focus on at Shield AI is basically the equivalent of self-driving car technology for aircraft. And you've probably heard or seen Elon Musk talk about, to get to self-driving cars, we need 99.9999999% reliability. 9 nines of reliability. And that's because us as consumers, the alternatives are really cheap, really easy. If I don't have a self-driving car drive me around, I'll just drive around. Not a big deal. And so I have a very high standard when I think about deciding to use a self-driving car. For the military, it's the complete opposite. The alternatives are horrible. And so you think about their willingness to accept risk, their willingness to accept something that is not as reliable. I remember in 2017, we were building an autonomous quadcopter, a self-driving quadcopter that would go inside buildings. And they said, our customers, who at the time were the SEAL teams, they're saying, hey, this is fantastic. Let us take this over to Iraq. And I was thinking, at that stage of the game, this was a prototype. It was something like 85% reliable. And I said, no, you're going to have a really awful experience with something that's 85% reliable. And they told me, and I knew they would say this, they were like, well, what else is a really bad time? Getting shot in the face, getting blown up. Like the alternatives are really poor, so we're happy to accept your 85% solution because it's way better than the alternatives. And that, that's a specific segment, but you see that scale up across the problem set in DoD. I have friends who are fighter pilots who say, we can't operate here because the odds of success, the odds of survivability are so low because there's surface-to-air missiles, there's radar sites. I said, well, help me understand what's, the survivability rates are. They're like, oh, it's less than 5%. We wouldn't even go into this area because we would absolutely get decimated. And so you see the DoD willing to push AI, autonomy, ML solutions much harder, much faster, with a willingness to accept risk. It's not to say like you can be satisfied with 85% reliability, but you don't need 9 nines of reliability. 99.99% gets you very far, and that requires far less investment to get to that level than 9 nines of reliability.
That's a great point. And of course, as a startup, right, being able to sell a product that is closer to minimally viable than the 9 nines of reliability makes a big difference in viability of building a company. You guys are each talking about ways in which defense is adopting machine learning, perhaps in a faster manner than expected. Anytime a big technology trend like machine learning comes along and starts to get adopted in a new field, it's going to change a lot about how things are done, right? It's going to change a lot about how war is waged, about how attacks are structured, how defenses are kind of prepared. Brandon, you've spent some time in the field. Like when you think about how this is going to change warfare, what are the ways in which you think it's going to make the battlefield?
Yeah, I'll just give you an example, and this is a recent one, something we talk at SHIELD. I'm sure Anduril and Lockheed are thinking about this too. Had the Ukraine put up a swarm of drones on their border that was powered by AI, that was intelligent, that patrolled that area, I don't think Russia would have ever invaded. AI and ML, and autonomy, they will enable the tools and the deterrents that are going to make America and our allies, strategic adversaries, think twice about ever, invading another country. The costs will just be so high to enact such actions that they're not going to do it. And so that's what really gets me excited about it, is the ability to provide stability, the ability to deter our adversaries. That is what's so exciting about the technology that I think all 3 companies here are working on.
Great. Yeah, I mean, deterrence was it's been a common theme for many of these leap ahead advancements that defense has seen. Gokul, you and I had a really interesting conversation about how in an algorithmically driven battlefield, how you defend changes, right? Obviously in a more traditional world, you just make the armor thicker on the tank, or you make the thing go faster, or whatever it is. In a world where we're defending against things like computer vision and so on and so forth, how do you think that that defense, I guess like the defense angle of defense will change?
Well, it's always been a cat and mouse game. So let's just talk through the history. So if you go 200 years ago, it's fundamentally people trying to look for other people. And so how do you hide from people? Well, you wear camo or something like that, and you're trying not to get spotted. Then think about 1920s, 1930s. Britain invents radar, and so now all of a sudden you can't hide from we're not trying to find you using binoculars. We're using a radar to try and find you. We're sending electromagnetic rays out. And so then that creates another cat and mouse game. So there's a dance between who can shoot out radar chaff, and how can I hide from someone's radar? I'm not trying to hide from your sight anymore. Well, now that we're moving into an AI world, that same cat and mouse game applies again. And what's really interesting is that as these countries evolve their capabilities, including our adversaries, they're not depending on their AI. A human isn't actually looking through all the data. There's way too much data to process for a human to look through. They're waiting for their AI system to give them an alert and say, hey, come take a look at this. And what that means is you don't have to beat the human anymore. You have to beat the AI. So going back to Brandon's example about the drones on the border, well, what is Russia going to try and do? If they were going to try and attack, they were going to try to figure out, how do I beat the drones? I don't have to beat the human. How do I find the weakness in those AI algorithms? And those are often very different than the weaknesses in a human brain. So you want to pull up, we've got a video here to show you guys that. And I think these have been demonstrated a lot in academia, but they're very real today. I think it's
yeah. Do you want to show the drone one or the super one?
Show the car one.
Okay, let's roll video 3.
Nope, the other one.
The other one, video 3, please.
There we go. So here's an example of, that's my Subaru right there. And what we've done is we've put a tarp on top of it. This is all digital. That is a bumblebee. And what you can see there is that the neural network is 100% confident that car is a bumblebee. And this is very easy to do. And here's the thing, a human looking out, let's say I'm in a helicopter looking down at the car, I'm pretty sure that's a car, and I know that I need to do something about it. But the neural network thinks that's a bumblebee and is never gonna bother the human to say, hey, someone might be on your border right now. And so think about we call this internally, and I'm sure every defense company is thinking about this. This is algorithmic warfare. We're moving beyond, the 1950s to 2000 was electronic warfare. How do I beat your radar system? Before that, it's human warfare. Now we're moving into algorithmic or AI warfare. How do I beat your algorithm? And that's a whole new cat and mouse game that kind of has evolved in this industry as these nations try and catch up.
It goes well beyond to this kind of like real-time evasion into the whole AI lifecycle. And if you're doing things like using publicly available data sets, you're using pre-trained models, you're using free and open source software, it opens all of these attack vectors for AI breaches, just like you would with cybersecurity. And I can poison a data set to fool a classifier in the same way that you could doing this real time. So those are all things that we have to consider when we're building these AI systems and deploying them.
I would also add what I think is really interesting about this cat and mouse concept. It's interesting from a business perspective because there's incentive from the customer being the DoD, to always have the best AI, the most up-to-date AI. If they're fooling one algorithm using deception techniques, whether it's pinning a bumblebee on something or building an inflatable SAM site, you're going to want that. You're going to want those edge cases. You're going to want that data back into your system so that you can train your models to learn on it. And the DoD's incentivized to get you that data back because they want the best capability out there. They don't want to be detecting bumblebees. They want to be detecting cars. And so we think about, okay, you want to have, the US is incentivized to have the best AI, but because there's other countries, it is truly a cat and mouse game, a race that everybody's going to be trying to get their cycle times down as much as possible when they start deploying new capabilities.
Speaking of new capabilities, in this cat and mouse game, it's always, the cat and mouse game is something that gives a slight, advantage to new entrants, right? Because you're not, you don't have a whole legacy product line of things that have fallen behind the cat and mouse game. And yet, so much of our defense infrastructure depends on that legacy stuff, right? I mean, we can't just have algorithms. We also do need, ships and things like that. Mike, I'd love to get your view at Lockheed. How do you think about, balancing that disruptor's dilemma, right? Where you've got, you can come up with things that will be tremendously effective, but perhaps make some product lines obsolete, and how you think about that.
Yeah, I mean, you nailed it. We have programs that have been running for over half a century that we would love to get machine learning onto, and they're just these mountains of technical debt that make it difficult or impossible in some cases. But those programs also have tremendous, very unique data sets that literally nobody else has access to. And also, we build a lot of platforms that nobody else has access to. So we have a lot of opportunity, if we can figure out how to do it, to deploy things onto those. At the same time, so on what are we doing to make sure that we're staying competitive, it's about investing in new platforms and in new technology. So we have a group in Lockheed that's fully committed to developing just AI solutions, putting them on new platforms, going and demonstrating them. We were at the same event, I think it was as Anduril, just a few weeks ago, doing a demonstration. So we're in the business of putting ourselves out of business from that perspective, while maintaining those legacy programs as much as they're needed and upgrading them when we can.
Makes a ton of sense. And when you think about the advantage, the relative advantages of being an incumbent, right? So we've already talked about kind of the advantages of being a new entrant, but there's obviously advantages to incumbency as well. When you think about it through a machine learning lens, what are some of the advantages of incumbency?
Well, I think I hit the one, which is unique access to platforms and data sets. That may be the biggest one. Obviously, we have very broad connections. We have global scale. We have 114,000 employees. And so from some perspective, like if, let's say, talking about talent, one way to find talent is to go out and compete with other companies, but another way is to grow our internal people. And we've made a big investment on doing that. And we can grow that skill set in-house. We've got a lot of people that we can do it with that are willing and anxious to do it. And smaller companies, I guess, have to go and find that talent. They don't have the opportunity to necessarily grow 1,000 people internally.
Great. Let's talk about talent for a minute, right? I mean, talent is the lifeblood of innovation, right? Defense has been an area where technical talent has been somewhat polarized, right? In places like Google, you see walkouts happening because of their participation in certain DoD programs, and the entire company kind of deciding not to engage DoD at all. Places like Google, they employ a not insignificant amount of data scientists, right? And so, as you guys think about hiring onto your teams, whether that's at Shield, Anduril, or Lockheed, how are you finding the talent climate to be? Maybe starting with you, Gokul.
Yeah. Well, it's no secret we're all here because we want to meet you guys, and we want you all to consider working at one of our companies. And so part of it is just getting out there and talking about what makes our field unique, why we think this is a really important problem. As I've said before, I think it is bigger than any one company. It is nation state level. And I think, for us, we're actually seeing a lot of folks become more excited. I joined Anduril in 2018, and since then we've actually seen less skepticism and more folks saying, this is a mission that I want to work in and work for. So I'm optimistic about that, and I think folks are, I hope, seeing the very real consequences of defense in the Ukraine-Russia situation right now. So the other part of this is just really talking through the ethics of it and how we approach it responsibly. And I think the one message I want to convey here, and then maybe Brandon, who's actually been an operator, will have more, is I actually think that the DoD is among the most responsible organizations I've ever worked with. It has real rules of engagement, it has real operating procedures, it has real policy, and deeply thought through policy. In fact, it has a whole AI policy. And so a lot of the skepticism or pushback that I've gotten, when talking with candidates is really about, well, do I want to be involved in like building Skynet or like a murdering machine? And that's really not what we're doing. And so that's really been a big thing for us to convey, and then the belief in the mission that we're all working on.
Brandon, I mean, you're a co-founder of Shield AI, so you've been on that journey of hiring great talent for some time now. What's your experience been, and have you seen or felt any shift, either to the positive or negative, in terms of attracting the best talent?
Yeah, I think most people are open-minded. I think you have these very loud, small, segments of populations that draw a lot of attention. But I think at the end of the day, a lot of people understand the world's not black and white. And people are very interested in protecting the values that the United States stand for, which are embodied in our Constitution, embodied in our Declaration of Independence. They believe that stability and security are overall benefit to the world for when we think about our allied partners. And at the end of the day, I think that it matters a lot for people. So certainly I've come across the dogmatic, I've sent a LinkedIn message before to someone at Google. They're like, in no way in hell would I think about working in defense. I was like, okay, next. But sending it to, a colleague on their team, and, that person's working at Shield AI, from Google. And so it's just, people have their beliefs, but I think by and large, people want to contribute. They want to make an impact on the world. They're looking for, what I tell people, the best thing about working in defense or in national security, and this was true for me as a Navy SEAL, it's true for me as a co-founder of Shield AI, it's that The U.S. government, the U.S. military have to tackle the most challenging problems in the world, the largest, most challenging problems in the world. National security, global stability, those are really, really complex problems, and they need all the help that they can get. And that's what, attracted me to going back into the defense industry after serving, was the ability to make impact on these really complex, really challenging problems. And I, by and large, believe that the best people in the world, the best engineers, best leaders in the world, that is what they want at the end of the day. They want to make an impact on really hard, really challenging problems.
And when you think about making a big impact on challenging problems, one of the criticisms that has been has been leveled against the defense industry is that it is slow to innovate traditionally, right? I think this panel is really interesting because we've got Lockheed and startups, right? And so I think we have a panel to really provide a unique view here. But Mike, maybe starting with you, why do you think defense has been slow to innovate, or do you think it has been slow to innovate?
Yeah, I would disagree. I think historically, and of course I'm a little biased coming from Lockheed and our history with Skunk Works and the work that they did 50, 60, 70 years ago, and how rapidly they brought some of the most advanced aircraft still on the planet to fruition. I mean, some of those timelines are crazy, and the technologies that they had to invent. And we've seen this repeatedly. I think when people have the right vision, the right funding, and the right support, they're going to get the job done. And we've seen it happen over time. I think right now, maybe with AI, those things haven't fully aligned in the US, but maybe they're starting to. Certainly they align in the commercial sector first, and we saw the rapid growth and the technology demonstrations, and maybe AI is unique there, where historically I think defense innovated on things that then went to commercial. We think about like NASA and the stuff they developed for the space program and all the stuff that came out of that. And maybe AI is just doing it backwards. They figured out how to scale software and on the internet and web applications first in the commercial world, and then how to bring AI and ML to those to bring more monetary value to people clicking on things. And now defense is catching up to that. But once the vision aligns, the money is there, the people, you're seeing these companies, they're growing, big companies are investing. I think we're going to start to see the output of that really soon.
Got it. And Brandon, what's your experience been?
Yeah, I think one of the major so I think there has been challenge in innovating in the DoD, and I think it's one, just a systematic challenge of the department is that they put out all the money that they spend is based on something called a requirements process, which is basically people in the DoD writing requirements down and saying, this is the product I want, go build it. And I would equate that to, the old saying, if Henry Ford asked people what they wanted, they would say faster horses. And so the DoD has been getting faster horses for the past 20, 30 years because that's the process that the DoD built, that's the process that they instilled. And so what that has led to is an opportunity for companies like Anduril, for Shield AI, to say, you know what, we actually think that we can build a product that people want, because there's this gap here, because you have people focused on requirements, saying, where the customer's telling them this is what I want versus, hey, how can we best solve the problem? How can we tackle this problem? In 2015, even today, there's not a requirement for a quadcopter that goes inside buildings to explore. Crazy that, and we've built it. That requirement still doesn't exist, but that is selling. There is not a requirement for, when you look at the actual programs that are being built, you don't see a lot of autonomy or AI requirements, and that's because the DoD doesn't know how to build them. And so what that does is it enables companies like a Shield AI or like an Anduril to come in and say, you know what, I know what the technology can offer. I believe that people will want this at the end of the day because it's going to solve their problem. I can figure out the requirements and the money thing off to the side, but this is going to allow me to innovate at a much faster rate than the traditional defense industry.
I'll just add to that, I think both things that these guys have said can be true, and I just want to kind of put a bow on it, which is like historically, and as Brandon said, the DoD has been very good at making hardware. But and if you just look at the innovations that came out of the DoD, whether it's radar, GPS satellites, internet, fundamentally all of those were defense projects. Many of you probably went to graduate school. I did too. DoD paid for my grad program. They paid for my PhD. It was all DARPA funding. But what you're seeing is as this shift to software has happened, the DoD has started to fall behind. That isn't the thing that they can write a requirements doc, as Brandon said, and say, like, I need a box. The box should look this big. It should be blue, and the box should have like laser beams shooting out of it. Like they don't fundamentally know how to do it for these very iterative, fast-paced technologies. But I think just tying it back, the amazing thing about the DoD is that they are going to be risk takers because their mission is every day. They are preparing for, they're either protecting something from happening or they're preparing for a world that we don't want to see. We don't want to see Russia invade Ukraine, for example. And so when you have that strong mission pull, you can still innovate even if the bureaucracy is messed up. Speaking from personal experience, like Brandon, the DoD did not have a requirement for stop drones from hitting US bases. We started with a little quadcopter, and then 6 months later, I was literally in the Middle East, sitting on top of a building, putting my quadcopter down, and trying to hit a drone out of the sky that was attacking a US base. So, there's a real risk-taking ability and an ability to do it in a safe way, push the ball on these things that I think you just won't find in other industries, especially when you can go to where the mission is. And I think that, just to put a bow on it, like, this is a turning point in history right now, and I think everyone can kind of see that. And so I think that the DoD is once again waking up to, we have to get back to being the best at what we do. Otherwise, we could be in real trouble. This country could be in real trouble.
Speaking of drones, we've heard that example a couple times now. I think we have a pretty cool video on that, right? So.
Yeah, we got one last video. This is slightly
let's
different, but I just wanted to show you guys video
two,
two. This is a medium wave infrared imagery, and this is actually, I couldn't get the real video because of classification reasons, but this is an airplane flying away from a site. And what you'll see is this is a neural network trying to detect if it's an air vehicle or a bird, and as it gets farther and farther away, it starts to confuse them. I myself cannot tell at this range. All I can see is the exhaust coming out of the airplane, and it starts to basically say, oh, I think there's actually just two objects there, and they could be a bird, they could be an air vehicle, I don't know. This is just pure the neural network detecting. And you can see by January, we had been able to actually perfectly detect this thing flying away. And that's because medium wave infrared imagery is actually not visible to the human eye. And so there's way more information in there, there's way more bit depth in there that a neural network can look at and detect on than you and I can see. So even when it gets farther away, you and I can't tell that there's wings and things like that say this is an airplane, but the deep network can. I wanted to show this for two reasons. One, to just show folks the types of problems and the types of data sets that we get to work with. But two, if you played that video in reverse, if that thing was coming at you instead of going away from you, the ability for a machine learning model to detect that before a human can, that is seconds of response time, and that is the difference between people getting under shelter or being able to send a drone at it to take it out of the sky and save lives, and it being too late. And I think I just wanted to kind of stress the stakes at play here, the problems that we get to work on, and the types of data we get to do it with.
Yeah, and I think that kind of thing is illustrative of how different defense can be in a machine learning driven world, right? I mean, you think about the classic example of like, a lance corporal falling asleep on post at 2 a.m. or whatever, right? Like that's not going to happen for an algorithm.
Yeah, it's
right?
not going to sleep. Yeah.
So we'll go to questions in a few minutes, but last question that I'll pose to the panelists here directly is, what do you think is an appropriate ethical framework for the use of machine learning in warfare? Right? People have varying views on this, right? Some are clearly of the not at all camp, which I think is hard to do since it's like banning math. And then there are the people who are like, hey, like, what, just as aggressively as possible, right? What are your thoughts on that?
I'll start. I view it. I break it into three things right away. And the first is the process in which that you're using to develop the AI. So that's one part. The second part is the AI itself, and we could talk about bias and explainability and all of that. But you could ethically use an ethical process to build an AI, put it on a plane, and then maybe if that has unintended bias in it, the AI itself might be making unethical decisions or decisions that can be construed as unethical. And then the third part is you could have those first two parts be ethical, but then you could use it in an unethical way. So it's the application of it. So I think you can deconstruct it into those 3 different areas and then address them independently.
Got it. Any other thoughts?
Yeah, I'll just say, and Gokul touched a bit on this earlier, but one, the DoD has an ethics and AI policy, and it's very good. They spent like 18 months or something and spent tens of millions of dollars with policymakers and just, ethics, people who are subject matter and experts in ethics, and spent a lot of time thinking about how they would talk about and use AI in the DoD. And so that's a framework that Shield AI we read through, and we said, you know what, this makes a lot of sense. We're very comfortable adopting that similar framework. But I think it speaks more to just how the DoD, a lot of people don't realize this, but they are very, very responsible with amazing, with awesome power. I think about the Spider-Man line, with great power comes great responsibility. The DoD, sure, it has had its hiccups throughout history, but by and large, when you think about an organization that has maintained tons, many, many, many nuclear power plants over the history of the nuclear power plant, first introduced in the 50s, and have had 0 incidences with it. When you think about, yes, post World War II, our restraint in using nuclear weapons. I think the United States has this awesome power that we choose to wield in a very, very responsible way, by and large. And that's when I think about the power of AI, I agree. It is, with Putin, whoever leads in AI will rule the world. It's the most powerful one of the most powerful transformational technologies in the world. And I think the DoD, based on my history with them as well, is just such a good steward of powerful technologies.
Yeah, I don't want to take more time, but I think I completely agree with that. If there's one thing we're good at, it's committees and policy. We really thought through this one, guys. So the AI policy is quite good. The other thing I'll add is it's not just making weapons or nukes or something like that. A lot of what we think about is how do we empower the right people to make the right decisions before the situation forces them to, right? That's where you're using the AI. You're helping detect things earlier, find things faster, put the opportunity in the decision maker's hands. And then as Brandon said, the DoD actually is an extremely responsible entity. And if you get to work with them, it becomes very evident.
Great. Well, with that, I think we have time for 1 or 2 questions. We'll pass around a mic, so just raise your hand if you've got a question.
Thank you, guys. I have 2 questions. One is, what is the biggest challenge on the AI adoption in the defense industry? I'm from the financial industry, and I would say, data security and customer-facing type of decision making is where we've got to be really careful. And it sounds to me that that's different than in the defense industry. So I'll be curious, what's the challenge of adoptions in AI? And the second question is, you talk about talent. Is your talent pool relatively limited due to the top security or sensitivity of the work that you guys are doing? Mm-hmm. Thank you.
Okay, yeah. So for the first one, I think we touched on that a little bit, and it's kind of a mix. Like there's areas where it's really easy for us to deploy things. The customers are asking for it, and in fact, it's easy to deploy something even if it's not perfect, like the 85% reliability. But then there are other areas that are almost the exact opposite, and which maybe it's like legacy programs. We have a lot of scenarios where maybe something's been in place for a long time, and we've demonstrated that a machine learning model can do it better, but we've been unable to prove that it can't do it worse than the existing capability. And those scenarios are very hard to deploy into. It's like, you can't make this worse in any way. So I don't know, so that's kind of an indirect answer to the first one, but it just varies depending on where we're doing it. From a talent perspective, yeah, obviously all 3 of our companies, I'm sure, work at all different clearance levels. And, I hit this before too. Lockheed's doing a huge amount of internal upskilling in this area, and we're doing it across all the clearance levels. Is the talent harder to find at the different clearance levels? Probably, because there's less of that. Like, you're not going to come from a commercial company with a top secret clearance, probably. or not from the commercial sector at least. So you would have to, then we'd be stealing from competitors or these guys, so, and vice versa.
Yeah, exactly.
So that would make it harder, yeah.
If I could add, so when I think about adoption, I think about, I don't know, whatever that bell curve is where you talk about technology adoption, and I think about probably 10% of the DoDs there. It's like that's where we are, the early adopters stage right now. And so I think about the barriers. A lot of it's education, a lot of it's understanding. Talk at great lengths with our customers about, they're like, oh, first thing, like define AI. What do you mean? It's like, are you talking about computer vision algorithms? Are you talking about its application as it relates to autonomy? Are you talking about, using it as a reinforcement learning to train a system on a particular mission set? And so there's a big education piece. And then to the question about talent and national security, what I think is really interesting is like, and this is something that we talk about too, really the classified stuff, the secret, the top secret work, those are edge cases. And especially, so in a software world, you can bifurcate, you can compartmentalize those edge cases, and there is a core of work around software, around AI, around autonomy, around the infrastructure that, is simply on an unclassified level, it's almost on a commercial level, where that gives you greater access to more talent pools.
Do we have time for one more question?
I think we do one quick one.
Okay.
I'll try to make it quick. Appreciated your discussion of the differences of the defense environment and you're dealing with life and death. I'm in financial services and we're not. I did find some parallels though. When you discussed algorithmic warfare, it's true for us too. We are looking for not just models, but we're looking for models that are better than our competitors' models. And that advantage is temporary, right? Mm-hmm. We have to respond to advantages that our competitors have, and we have to develop temporary advantages of our own. And that gives a certain urgency to AI development, a little bit of a panic. In order to get the most emergent, the most experimental algorithms to be evaluated and applied, we have the tension that you can't just take software from the public and apply it to sensitive, secure internal data. You guys have that problem in an extreme. So do you see the defense industry handling that intake of public algorithms differently as software gets taken off the internet, scanned, secured, licensed, and applied to the high side?
Yeah, I can start there. I think you're dead on, and those parallels are the exact same. And so, I think you can think about it as any advantage can only be sustained for so long. You're basically buying yourself a time delay by doing all of these things. And then really the trade-off that you're making is if, I think about, I'll make an analogy to like World War I. In World War I, we like dug trenches. Okay, nobody could hit us hopefully nobody could hit us because we were in the trenches. But we couldn't do anything either. It's not like you're getting much done down in the trenches. And so the trade-off that we're thinking about is like, if we make the development environment so insane that it's so hard to get open source tooling in, it's so hard to move it up to the classified level, get the real data sets, we are leaving behind this industry that's moving so fast. Yeah, we're secure, but we have the worst stuff. But on the flip side, if we're just like straight up going on GitHub, copy pasting some code and being like, all right, let's rock and roll, you've just opened up a giant vulnerability to yourself. And how do you balance that? I think that is the entire game. I wish I had a perfect answer for you. I bet you and I could talk offline about various strategies, but I think this is the entire game right now.
Yeah, the only thing I would add to that too is that it's very compartmentalized. So even if you achieve that on one program, you'd have to repeat that entire process on all of your other programs because they can't share anything. So that's a huge problem for us, especially since we've been around forever. We've got 1,000 programs. Any success in one area, one thing we've been working with our customers on is when we have a success on one of your programs, how can we copy and paste that into your other programs?